Hey guys, welcome back to Voltage Learning. In today's video, we have 4 parallel resistors powered by a 9-volt battery. We need to find the total current in the entire parallel circuit. So let's get right into it. We can solve this problem in 3 quick steps. In step 1, we simply write the equation for equivalent parallel resistors. We know that parallel resistors follow the reciprocal rule, meaning that 1 over the equivalent resistance is going to be equal to the sum of the reciprocal of all the resistances. In this case, since we have 4 resistors, the 1K, the 2K, the 5K, and the 10K, there's going to be 4 terms in our equation, meaning 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Next, in step 2, we're going to plug into that same equation using the values of the resistors. So 1 over the equivalent resistance is equal to 1 over 1K plus 1 over 2K plus 1 over 5K plus 1 over 10K equals 0.0018. However, we can't forget that we still need to invert this. So 1 over 0.0018 equals 555.56 ohms. Now, in our final step, we're simply going to use Ohm's law to find the total current. In a parallel circuit like this, it's important to note that all the resistors encounter the same voltage, but they all have different currents. This is a fundamental rule of parallel resistor networks. Now, knowing this, we can plug the values into Ohm's law, meaning I is equal to V over the equivalent resistance is equal to 9 volts over the 555.56 ohms we calculated in step number 2 gives us a final answer of 0.0162 amps or 16.2 milliamps. So to summarize in our problem, we first wrote the equation for parallel resistors. We found the value of the equivalent resistor, remembering to always take the reciprocal. And finally, we plugged in all of our values into Ohm's law to find the total current of the parallel resistor network. So if you want to see more problems like this and go through more technical interview prep, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.